Yes, a transformer can be used to create a neutral from a 240-volt supply derived from two 120-volt legs. Specifically, an isolating transformer is applicable in this scenario. An isolating transformer provides electrical isolation between the primary and secondary windings. This isolation offers protection and can be instrumental in creating a derived system with a neutral. In your situation, connecting the two 120-volt legs to the primary side of the isolating transformer allows the secondary side to provide a 120/240 volts output, complete with a neutral. The benefits of employing an isolating transformer include, firstly, electrical isolation, which safeguards the connected camera system from power surges and electrical disturbances. Secondly, the creation of a new electrical system that includes a neutral conductor, which is a requirement of the camera system. Thirdly, it offers a relatively straightforward and cost-effective solution. Several crucial factors must be considered when selecting an isolating transformer. Firstly, the power rating of the transformer must be adequate to support the load of the camera system. This rating is typically expressed in volt-amps or kilovolt-amps. Ensure the transformer's capacity meets or exceeds the camera system's power requirement. Secondly, the transformer must be designed to withstand outdoor environmental conditions. Look for an M3R or similar rating to ensure protection against rain, snow, and other elements. Thirdly, proper installation and grounding are paramount for safe and effective operation. The transformer must be grounded according to local electrical codes. Consult Article 250 of the National Electrical Code, or NEC, for detailed grounding requirements. To elaborate on the selection criteria, consider the following technical aspects. Firstly, transformer kVA rating. Calculate the total volt-amps required by the camera system. Add a safety factor of at least 25% to account for inrush current and future expansion. Select a transformer with a kilovolt amps rating that exceeds this calculated value. For example, if the camera system requires 500 volt amps, multiply that by 1.25 to get 625 volt amps. Therefore, a transformer rated for at least 0.625 kilovolt amps is required. Secondly, primary and secondary voltage ratings. The primary voltage rating of the transformer should match the available supply voltage, which is 240 volts derived from two 120 volts legs. The secondary voltage rating should match the required voltage for the camera system, typically 120/240 volts with a neutral. Thirdly, isolation voltage. The isolation voltage rating specifies the dielectric strength between the primary and secondary windings. A higher isolation voltage provides better protection against voltage transients and electrical noise. A minimum isolation voltage of 1500 volts is generally recommended. Fourthly, impedance. The impedance of the transformer affects the voltage regulation and fault current. A lower impedance transformer provides better voltage regulation but also results in higher fault current. Consult with a qualified electrician to determine the appropriate impedance for the application. Fifthly, temperature rating. The temperature rating of the transformer indicates the maximum ambient temperature at which the transformer can operate safely. Choose a transformer with a temperature rating that is appropriate for the outdoor environment. A temperature rating of 40 degrees Celsius or higher is typically recommended. Sixthly, enclosure type. The enclosure type protects the transformer from environmental conditions. An M3R enclosure provides protection against rain, snow, and ice formation. An NO4 enclosure provides protection against water and dust. Choose an enclosure type that is appropriate for the specific application. Seventhly, efficiency. The efficiency of the transformer affects the operating cost. A higher efficiency transformer consumes less energy and reduces operating costs. Look for a transformer with a high efficiency rating, typically 95% or higher. Eighthly, safety standards. Ensure the transformer meets relevant safety standards such as UL or CSA certification. These certifications indicate that the transformer has been tested and meets safety requirements. To elaborate on installation best practices, consider the following points. Firstly, mounting location. Choose a mounting location that is accessible, well ventilated, and protected from physical damage. Avoid mounting the transformer in direct sunlight or in areas where it may be exposed to corrosive substances. Secondly, grounding. Ground the transformer according to the requirements of the NEC Article 250. Use a grounding electrode conductor of the appropriate size and connect it to a grounding electrode system. Thirdly, overcurrent protection. Provide overcurrent protection for the transformer using fuses or circuit breakers. The overcurrent protection devices should be sized according to a transformer's kilovolt amps rating and primary voltage. Refer to NEC Article 450.3 for transformer overcurrent protection requirements. Fourthly, wiring connections. Use appropriately sized conductors for all wiring connections. Refer to NEC Table 310.16 for opacity ratings of conductors. Ensure all connections are tight and secure. Use appropriate connectors for the type of conductor being used. Fifthly, labeling. Label the transformer with the primary and secondary voltage ratings, kilovolt amps rating, and other relevant information. This will help prevent accidental misconnections or overloads. Sixthly, inspection. Inspect the transformer regularly for signs of damage or deterioration. Check for loose connections, corrosion, and overheating. Repair or replace any damaged components immediately. Seventhly, documentation. Maintain accurate records of the transformer specifications, installation details, and maintenance history. This information will be helpful for troubleshooting and future maintenance. Eighthly, qualified personnel. Only qualified electricians should install, maintain, and repair transformers. Working with electrical equipment can be dangerous, and it is important to follow all safety precautions. Regarding grounding requirements, adhere strictly to NEC Article 250. This article outlines the requirements for grounding and bonding electrical systems to ensure safety. Firstly, grounding electrode system. The grounding electrode system should consist of a metal underground water pipe, a ground ring, rods, or plates, or other approved electrodes. The grounding electrode system should be bonded together to form a low impedance ground path. Secondly, grounding electrode conductor. The grounding electrode conductor connects the grounding electrode system to the equipment grounding bus in the transformer enclosure. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded conductors. Thirdly, equipment grounding conductor. The equipment grounding conductor connects the non-current carrying metal parts of the transformer and the connected equipment to the equipment grounding bus in the transformer enclosure. The size of the equipment grounding conductor is determined by NEC Table 250.122 based on the rating of the overcurrent protective device. Fourthly, bonding. All metal parts of the electrical system, including conduit, enclosures, and equipment, should be bonded together to form a continuous electrical path to ground. Bonding helps to minimize voltage differences and reduce the risk of electric shock. Fifthly, separately derived system. When using an isolating transformer to create a new electrical system, the secondary side of the transformer is considered a separately derived system. The separately derived system must be grounded according to the requirements of NEC Article 250.30. This includes establishing a grounding electrode system at the location of the transformer and bonding the neutral conductor to the grounding electrode system. Sixthly, ground fault protection. Ground fault protection is required for certain electrical systems to detect and interrupt ground faults. Ground fault protection is typically required for 480 volt systems and may be required for other systems depending on local codes. Consult NEC Article 230.95 and Article 240.13 for ground fault protection requirements. To further clarify the NEC references, consider the following. NEC Article 250 covers grounding and bonding. NEC Article 450 covers transformers. NEC Article 310.16 covers ampacity of conductors. NEC Article 230.95 covers ground fault protection for services. NEC Article 240.13 covers ground fault protection for equipment. When selecting a transformer, consider the inrush current. Transformer inrush current is the peak instantaneous current drawn by a transformer when it is first energized. This current can be significantly higher than the transformer's normal operating current, typically 8 to 10 times the full load current. Inrush current can cause nuisance tripping of overcurrent protection devices such as circuit breakers and fuses. To mitigate the effects of inrush current, consider the following. Firstly, use slow-blow fuses. Slow-blow fuses are designed to withstand short-duration overcurrents without tripping. They are commonly used in transformer circuits to prevent nuisance tripping due to inrush current. Secondly, use circuit breakers with high magnetic trip settings. Circuit breakers with high magnetic trip settings are less sensitive to short-duration overcurrents. They can be used in transformer circuits to prevent nuisance tripping due to inrush current. Thirdly, use inrush current limiting devices. Inrush current limiting devices such as soft starters and reactors can be used to reduce the magnitude of the inrush current. These devices gradually increase the voltage applied to the transformer, which reduces the inrush current. Fourthly, size the overcurrent protection devices appropriately. The overcurrent protection devices should be sized to protect the transformer from overload and short circuits, but they should also be able to withstand the inrush current without tripping. Consult NEC Article 450.3 for transformer overcurrent protection requirements. Fifthly, use a transformer with low inrush current. Some transformers are designed with low inrush current characteristics. These transformers typically have a higher impedance and a lower core flux density. Consult the transformer manufacturer for inrush current data. Regarding safety considerations, always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Follow lockout/tagout procedures to prevent accidental energization of the circuit. Work in a well-ventilated area to avoid exposure to hazardous fumes or gases. If you are not qualified to work on electrical equipment, contact a qualified electrician. When installing the transformer, ensure that it is properly supported and secured. Use appropriate mounting hardware and follow the manufacturer's instructions. Avoid mounting the transformer in areas where it may be subject to vibration or physical damage. Connect the transformer to a dedicated circuit. Do not share the circuit with other loads, as this may overload the circuit and cause a fire hazard. Use appropriately sized conductors for all wiring connections. Refer to NEC Table 310.16 for ampacity ratings of conductors. Ensure all connections are tight and secure. Use appropriate connectors for the type of conductor being used. Protect the wiring from physical damage. Run the wiring through conduit or other protective raceways. Avoid running the wiring in areas where it may be exposed to moisture, chemicals, or extreme temperatures. Label all wiring connections clearly. Use wire markers or labels to identify the purpose of each wire. This will help prevent accidental misconnections or overloads. Inspect the transformer regularly for signs of damage or deterioration. Check for loose connections, corrosion, and overheating. Repair or replace any damaged components immediately. Keep the area around the transformer clear of debris. Do not store flammable materials near the transformer. Ensure that the transformer is properly ventilated to prevent overheating. Do not overload the transformer. The transformer should be sized to handle the load of the camera system plus a safety factor of at least 25%. If the transformer is overloaded, it may overheat and fail, which could cause a fire hazard. If you have any questions or concerns about the installation or operation of the transformer, contact a qualified electrician. Working with electrical equipment can be dangerous, and it is important to follow all safety precautions. Furthermore, ensure all work complies with local electrical codes and regulations. These codes are in place to protect people and property from electrical hazards. Obtain the necessary permits before starting any electrical work. Schedule inspections to ensure that the work is done properly and safely. Failure to comply with local electrical codes can result in fines, penalties, and even legal action. Remember to consult with a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and effectively install and maintain electrical equipment. They can help you select the appropriate transformer for your application, ensure that it is properly installed, and troubleshoot any problems that may arise. Do not attempt to perform electrical work if you are not qualified. Working with electrical equipment can be dangerous, and it is important to follow all safety precautions. Hiring a qualified electrician is a worthwhile investment. They can help you avoid costly mistakes, ensure that the work is done safely and properly, and provide peace of mind. When choosing an electrician, look for someone who is licensed, insured, and experienced. Ask for references and check their online reviews. Get a written estimate before starting any work. Communicate clearly with the electrician and ask any questions you may have. By following these guidelines, you can ensure that your electrical project is a success.